So here derive the transfer function y by x. This is not a standard loop. Reason because, so this is a feedback loop, but you have a connection which is joining in between. So that is why this is not a standard loop. So you have to assign the variables and derive the transfer function. So now can you hear my voice? Is it clear or not clear? Is there any disturbance? So this is not a standard loop. So you have to solve the problem as if it is a new problem. So this is variable x, this is variable x, this is also variable x. This is, let's say, new variable a, this is b. This connection should come here. This connection is from here to here. So this is, let's say, c. This is let's say c. This is, let's say, d. This is y. So this is also y. Yes. So how many variables you have written? How many variables you have written? A, B, C, D. 4 variables. So how many equations you can write? X into GA is equal to A minus Y equal to B, B into GB equal to C plus X is equal to D into G is equal to Y. See, remember one thing, my number of variables are 4, my number of equations are 5. This is an indication that the problem is going in the right direction. If you have done a mistake, either you will end up having 6 or 7 number of equations or 4 equations. So the number of equations should be just one higher than the number of variables. See, the number of equations should be just one higher than the number of variables is what I'm trying to say. You start reducing the variables. How do you start to d into g? See, what is d? C plus x into a minus y. What is a? X into g. Like this you do, and then so what is c is bgb plus x into gc. What is b is a minus y into gb plus x into gc. What is a? X into ga minus y into GB plus X into GC. This is Y. Can you try to solve one more problem so that it will be good for practice? So just take one more problem. So derive the transfer function y by x here. This is also not a standard loop. Plus and my plus. This is plus and plus. This is plus and minus. So here also you have to start assigning the variables. Let's say this will be x only. This will be A, this will be B, this will be C, this will be D, this will also be D, this will be E. So how many variables you have? A, B, C, D, E. So how many equations you will write? So first thing is x minus D equal to A into G, B into equal to C, C plus E equal to D, D into GC by GI is equal to E. I think there is some problem in the Zoom again. So I have lost the contents. I hope you can solve this problem on your own. I think I have missed the entire system again. I hope you can solve this problem on your own. So like x, if you remember the variables x minus a equal to d, d, x into gc by ga is equal to e, a into gb is equal to b, b into gc equal to c, c, sorry, first one is x minus d equal to a, x minus d equal to a. So c plus e is equal to d, d into gi is equal to y. So overall you have 6 equations, 5 variables, a, b, c, d, e. So 5 variables and 6 equations. Yeah, you will get more same answer. So the answer that you will get is GC 1 plus GA GB 1 plus GB GC. So can I start next column? Next is concept of offset. So next one is concept of offset. C plus E equal to D. It is not C minus C because I have given the plus plus sign there. So offset. What is offset? What is the definition of offset? So how do you define offset? So we are moving to the next topic, offset. How do you, what is simple offset is, what is the response that you have expected minus what is the actual. This is what you define it as offset. What is the response that is expected minus what is the response that is actual. Suppose if I have a control loop, let's say, so I'll draw a standard control loop. GC, GF, GM, GP, GM, plus minus, plus. Y, this is load, this is X. This is X. Suppose if there is step change in load, then what do? What is the response that you expect? So basically at steady state, your X is equal to 0, U is equal to 0, and Y is also equal to 0. All are zeros because these are deviation variables, no? Suppose if you are talking about this as a CSTR, you are talking about my capital X is nothing but, let's say, set point, which is small x is 60 degrees. My small u is 40 degrees, which is inlet temperature. My small y is also 60 degrees. So this is the inlet temperature. This is, let's say, set point, and this is outlet. At steady state, all are same. Suddenly, u has become, let's say, 50 degrees centigrade. Suddenly u has become 50 degrees centigrade. Then suddenly u has become 50 degrees centigrade. Then what is the response that you expect in Y? What is the response that you will expect is your small y 60 degrees will slowly start it to deviate, and controller will bring back the value back to 60 degrees. Correct or not? For changes in the load. For changes in small u. Now if you plot this as a capital Y, so capital Y starts to deviate from 0, so it will deviate, and then finally it should be 0. Clear? So what is the response that I expect? Is for changes in the load. For changes in the load, my response expected, that means at steady state, I expect 0 again, because the value starts from 0. The value starts from 0 and then it deviates because there is a change in the load. Finally, controller will bring back the value back to 60 degrees. So what is my offset for changes in the load? For changes in the load that I'm saying. For changes in the load, what is the offset that I expect is what is Y expected minus what is Y actual. What is the Y expected is 0 minus what is Y actual is Y infinity, you have to calculate. So the offset is what is, suppose if your Y actual is also 0, then offset is 0. That means there is no offset. Suppose if you are expecting a rank of, let's say, 90 in the GATE exam, suppose if you get exactly 90, then your expectation is equal to reality. That means offset is 0. So something like that. So my expectation is 0 in the load changes. So what is my actual is, I need to calculate. In the problem, I need to calculate what is the offset. Is everybody with me? Okay, so then next point. Suppose if you change the set point to 70 degrees, that means what you are doing, your small x is 70 degrees. Then what is capital X? 10 degrees. Then what happens? Your small y is 60 degrees. Suddenly you have made the set point 70 degrees. Slowly small y starts to rise and then finally it has to settle at 70 degrees. This is my expectation. So my controller expectation. So then what is my capital Y is, it starts from 0. Capital Y starts from 0 and then capital Y will increase and then finally capital Y should become 10 degrees. So what is my offset here? What is my offset here is, what is my Y expected minus what is my Y reality. What is my Y expected? This is what is I expect. This is the response that I am expecting. So what is my Y expected is 10 minus what is my Y reality is I need to calculate. So offset might be, let's say if the controller is not successful in making it 70. Suppose if the reality is something like this, let's say reality starts from 0, maybe it is settled at, let's say 69 degrees. Then what happens? This is, let's say, actual. Then what is my offset is, I'm expecting a change of 10, but I got a change of only 9 degrees. So what is my offset is 1. So this is changes in set point. So this is offset changes in set point. So changes in the set point is your, what is the change that you have given minus what is it actually achieved, because your Y response has to follow the set point. Whereas in the previous one, what is my response is, I am expecting, this is what is my expectation. Clear? So it is 0 minus Y infinity. Here it is 10 minus Y infinity. So basically, but what is the fundamental definition of offset is, what is your expected response minus what is it you are achieving, is what is the offset. Just to take 2 minutes time and understand this concept. Any doubts? So Y infinity, which is found by the new steady state, that is what is actually Y actual. Let's start a problem. Just take this one. So what is question is, first one, for a step change in U, what is offset? Second question, for a step change in R, what is offset? Kc is as it is. There is no value for Kc, so you have to solve as it is. Kc will be as it is. You have to solve with the Kc. Take it as unit step change, for a unit step change. Zero. In both the cases, is it zero or first one zero, second one some value? So first thing is, let's derive what is the transfer function y by u. Y by u. So what is y by u? 1 by 2s divided by 1 plus kc into 2 into 1 by 2s. So what do you get? S by s plus 2 kc is what is 1 by u. Correct or not? Now, so what is y by u is equal to s by s plus 2 kc. So what is u? 1 by s. What is y? 1 by s into s by s plus 2 kc. So now we need to find out what is the final value. So how do you find final value from this one, y of s? You can apply the final value there. Limit s tends to 0, s into y of s. So limit s tends to 0, s into 1 by s 1 by s into s by s plus 2 kc. So this s and s will cancel. When you put s equal to 0, so what is the final value is 0. So what is offset is, so when there is a change in the load, what is your y expectation minus what is y actual? What is your expectation is 0. What is your reality is also 0. So offset is 0. So your offset is 0 because your expectation for changes in the load is 0. Two S, 2 kc. That is not 25. Don't take it as 25. This is 2s. Now what is y by r? Kc we are equal to 0, we have not taken. Where we have taken Kc equal to 0? There will be S, no, in the numerator, S. 2S here cancel out. Okay, okay. So I think one S by 2 into S plus 2 Kc. Is it right? Yeah. This will be 2, but doesn't change the answer basically. 2, 2, but the answer will remain same. See, y by u, when you're talking about y by u, r is equal to 0 by default. Don't take r because simultaneously u and r cannot change. See, this is when for a step change of in u, what is offset? That means when changes there on u, r will be silent. Simultaneous changes load, simultaneous changes set point is not there. See, in the numerator there won't be S. Why there won't be S? Because if you take LCM and then S will come in the. Okay. U equal to 1 by S given, no? See, is this transfer function right or wrong? So there will be no S in the numerator, no? Yeah, this is wrong. This will be 1. Is it right? 1 by 2S plus 2 Kc. Okay, this will be 1. This will be 1. This will be 1. So if you put, then what do you get is then so let's solve freshly. I think we have done some mistake in there. So here we have done a mistake. So this is 1 by 2 common S plus Kc. Is this right or wrong? Transfer function. Just confirm me. Y by u is equal to 1 by 2 into S plus Kc. Now what is u equal to 1 by S? Because it is given. So what is y of infinity is limit S tends to 0, S into 1 by S into 1 by 2 into S plus Kc. SS will cancel 1 by 2 Kc. So what is offset is expectation is 0 minus reality is 1 by 2 Kc minus 1 by 2 Kc. This is the offset. So is it right? Now next one, write y by r. So what is y by r is Kc into, what is the control loop? 2 into 1 by 2s divided by 1 plus Kc into 2 into 1 by 2s. So 2 will cancel, 2 will cancel. So Kc by S plus Kc. Is it right? Okay. Now R is equal to 1 by S. So what is y of infinity now? Limit S tends to 0, S into 1 by S into Kc by S plus Kc. So now S and S will cancel. So if you put S equal to 0, then this is 1. What is offset is y expectation minus y infinity. What is y expectation is 1. And there is a change in the set point 1, but what is actually achieved is also 1. So your offset is 0. So just take 2 minutes time and everybody digest the answer. Is there anything wrong in the? Why the expected is 0? Because when there is a change in the load, this is the response that you are expecting. For changes in the load, what is your response? Your steady state will start and it disturbs, and the controller should bring back to the previous steady state, which is 0. Clear? So y by r is not, s will cancel, but you have to take LCM, no? If you take LCM, s plus kc will come now. So what is the offset for the load is minus 1 by 2 kc. Offset of load changes is minus 1 by 2 kc. Why is 1 in the second case? Because when you change the set point by 1 unit, your response should also change by 1 unit, because you have to follow the set point. No, suppose assume that your CSTR is operating at 60. Now my set point is 60, and my temperature is also 60. Suppose if you make the 60 to 61, if you change the set point 60 to 61, then what do you expect? You expect the response to become 61, no? Or do you expect to become 0, 60? Is everybody clear? Offset. See, why expectation is 1? Because, so imagine, look, now just listen to me. Suppose now your temperature set point in a CSTR is 60 degrees. So your temperature of the CSTR in the plant is also 60 degrees. Fine, everything is under steady state. Suddenly you want to operate the CSTR at 70 degrees. Then what do? You make the set point 70 degrees, no? Then what is the temperature of the CSTR in the plant after, let's say, infinity time, let's say at steady state? So you expect the temperature of the CSTR also to become 70, no? Not 60, because you are changing set point means you are intentionally want to operate the reactor. Set point is something which you are giving. Load changes are coming because of there is disturbance. Load is a disturbance, set point is not a disturbance. So if there is a changes in the load, the system will make sure that the value will become 60 again. But if you intentionally change the set point from 60 to 70, the temperature of the CSTR should also become 70. Why you have made it to 70? Because you want to operate the reactor at 70. So that is why here, when you change the set point by 1 unit, that means you are expecting the response also to change by 1 unit. Clear? So let's solve one more problem. See, a proportional controller, there will be offset, not for all the cases. There may not be offset also. There is a chance of offset in the proportional controller, but there is no guarantee that always there should be an offset. So just take this problem. First one, for U equal to M by S, what is offset? Now you are changed by M units. Second one is x equal to m by s, what is offset? M is m units. M units, some m units. M can be 10, M can be 20, M can be anything. No, offset may not be zero for all the cases. Offset may be zero or may not be zero. We can't say. There is a chance of offset also. Then what is y by u here? Y by u is 1 by s plus 1 by 1 plus kc by s plus 1. 1 by s plus 1 plus kc. This is 1 y by u. So what is y by u is 1 by s plus 1 plus kc. What is u equal to 1 by s? What is y equal to 1 by s? What is y of infinity? Limit s tends to 0, s into, sorry, this is m by s. M by s, 1 by s plus 1 plus kc. S will cancel, s equal to 0, m by 1 plus kc. So what is offset? For load changes, your expectation is 0, minus m by 1 plus kc, minus m by 1 plus kc. This is for load changes. So now what is next one? Y by x. What is y by x is kc by s plus 1 by 1 plus kc by s plus 1. So kc by s plus 1 plus kc, which is y by x. Now what is x? M by s. Now what is y of infinity? Limit s tends to 0, s into m by s into kc by s plus 1 plus kc. S will cancel. So this is mkc divided by 1 plus kc. Now what is offset? What is your expectation now? What is your expectation now? Y expectation minus y infinity. What is your expectation is m. Because your set point changes by m units. So your response should also change by m units. Don't take it as 1. So let's listen. If you change the set point from 60 to 70, you expect the temperature of the CH to go from 60 to 70. Clear? M minus mkc by 1 plus kc. So which will be m by 1 plus kc. Just take 2 minutes time and read the entire offset again. Understand. We'll go to another concept. Can we solve one more problem in the offset? Are you comfortable? So let's solve one more problem in the offset, just to if somebody having, because this is something which is actually important problem repeating in every year. So whatever I am teaching now, writing is actually a gate problem. G1, G3, Y. G2, this is D. This is D. This is plus, this is plus, this is plus, this minus. So what is G1 is 1, G2, G3, both are 1 by S plus 1. See, this is not a standard loop. So first thing, for D equal to M by S, what is offset? This is a tough problem. For YSP equal to M by S, what is offset? This is a tough problem because this is not a standard loop. You have to derive the transfer function first and then find out the offset. Take time, take 10 minutes, but this is a gate problem. 4 marks gate problem. So D is the load. D is the load. D is the load which is going here like this. Plus plus. This is G2. So why? This is why. This is plus plus. This is plus minus. So here this is also plus plus. Just first thing is assign the variables. Let's say this is A, this will be B, this will also be B, this will be B, this will be Y. So this is, let's say, C. D is already signal, so I can't take D. This is E. This is, let's say, F. This is F. This is, let's say, H. So basically, A, B, C, E, F, H. You have put 6 variables. So how many equations you can write? 7 equations you have to write. Answer is minus m by 1 plus 2 kc, m by 1 plus 2 kc. So I'm not going to derive the transfer function since we have already derived many transfer functions. So I'm just giving the y final value. So what is y by d is g3 by 1 plus kc into g1 g3 plus g2. This is what you get y by d. So d is not taken because d is actually load. No, that is why I have not put d as another variable. D is not variable here. These are something that you have created as another variables. So what is y by ysp you get? So these are the first things that you have to derive. Y by ysp, which is equal to kc into g1 g3 plus g2 divided by so what you get is kc into First step is get these two transfer functions. So everybody got these two transfer functions. So once you got these two, then let's solve this one. After substituting 1 by s plus 1, then what is y by d you get is y by d is equal to 1 by s plus 1 divided by 1 plus kc into 2 by s plus 1. So 1 by s plus 1 plus 2 kc. What is d by m by s? So what is y of infinity? Limit s tends to 0, s into m by s into 1 by s plus 1 plus 2 kc. S will cancel. So if you put s equal to 0, 1 by 2 kc. So this is y of infinity. So now what is offset? What is offset is, what is your expectation? 0 minus m by 2 kc. Offset is m minus m by 1 plus 2 kc. Now this is for the load. Now what is y by ysp? What is y by ysp is you get 2kc by s plus 1 plus 2kc. We substitute the values. What is ysp? M by s. What is y of infinity is limit s tends to 0, s into m by s into 2kc by s plus 1 plus 2kc. S and s will cancel. What is y of infinity is m into 2kc by 1 plus 2kc. What is offset is, what is your expectation? M minus y infinity. So if you substitute this one, you will get m by 1 plus 2kc. So why y expectation is m? Somebody asked me the same question. We have solved the previous one. Simple question. If you change the set point of CHTR from 60 to 70, you will expect your response to become 60 to 70 only, no? So that means how many units the set point changes, that many units the response should also change. So here in this problem, if you observe one thing, if Kc increases, offset decreases. Kc increases, offset decreases, because Kc in the denominator, this problem and previous problems also. How to reduce offset is to increase the Kc. So when changing the load, we can't take the offset as 0. We have to calculate. This is 0 is not offset. This is response expected. Generally, the offset in the load and offset in the response will be, or let's set point are same. So like in the previous problem, this problem, we are getting the